You can make fireworks in a jar.
Okay, so this is a great little demo for talking about IMFs and solubility. And so this is going to be AP Chem topic 3.10, which is solubility. So in order for two things to dissolve in each other and make a solution, they need to have similar intermolecular forces. So when we look at this fireworks in a jar demo, you can see that the food coloring did not dissolve in the oil. You saw the little droplets stay kind of intact, but then once it fell through the oil and hit the water layer, then it started to dissolve. So what does that mean? That means that the intermolecular forces in the dye will be similar to the intermolecular forces in the water. So we know that water is polar, and we also know that water does hydrogen bonding. We're going to put the hydrogen bonding to the side for the moment because we're not going to actually get into the weeds with the molecular structure of a dye. But we can assume that because the food coloring did not dissolve in the oil, but it did dissolve in the water, that the food dye is also polar. So there's a little memory aid for this. It is not a justification, but it is a memory aid, which is like dissolves like. So basically the idea here is that in order for two things to mix together, they have to have a reason to be attracted to each other. So the more attracted they are, so the more similar their intermolecular forces, the more likely they are to form a solution or a complete solution. Okay, so what does that look like? Well, so if you have an ion can dissolve in a polar substance like water, okay? And so the reason that happens is because your ions have full charges. And then the water has got these partial charges, and water has got these pretty strong, relatively speaking, partial charges. And so when you have something like sodium and chloride, and then you drop it into water, what can happen is that your partial charges in your water can be attracted to the full charges on your ion. And so this is not necessarily proportionally right here in terms of the number of waters that are attracted to the ion, but I can just show you a quick drawing. So this is what this might look like. So the positive sodium gets surrounded by the partial negative area on the oxygen of water. And then if you had the chloride, then it would be surrounded, of course, by water as well, but chloride is negative, and so it would be attracted to the partial positive ends of water. If you have two polar substances, they can form a solution with each other as well, and so like your dye and your water, because the partial negative area can be attracted to the partial positive area between the two substances, and so they can fully mix with each other. Now, let's talk about the oil in the water and why they don't mix. So oil is nonpolar and water is polar. And so if you have water and oil, you can shake them and they will mix together for a few seconds, but you can actually watch them separate back out again. And the reason they separate back out again is because their intermolecular forces are different. So as they're moving around, the water molecules will find other water molecules and be attracted to the other water molecules. And so then that will form its own layer, and you can actually watch that start to separate out. Hang on, I think I've got an example. Here's your water, here's your oil, here's your oil, here's your water. If I shake it, I need to make sure that cap is on really well. If I shake it, I can mix them up, but you're gonna see that they start to form layers again pretty quickly. So the water is gonna find the other water at the bottom, and then the oil is going to separate up to the top. Now, where they end up is an application of density, but the water's finding other waters, and then the oil is left to its own. So the oil attracts to itself through London dispersion forces, which are generally the weakest intermolecular force. And then, of course, the water hydrogen bonds with other water. But there you go. That's why things dissolve or don't dissolve in each other. But again, remember, the justification here is intermolecular forces. They either have them in common or they don't. And when you're answering questions about that, you need to discuss the first substance and the second substance independently and then talk about how they would mix together.